Hi everyone. Today's lesson comes from Unit 1.1, Notes number 6, Identifying Properties and Postulates. Our first goal for today is to be able to identify some properties from algebra. Our first property is the substitution property of equality. And it says, if A equals B, then either A or B may be substituted for the other in an equation. So if we have something that says, if A plus C equals 7, and let's say we know that C is equal to 2, then we can say A plus 2 equals 7. So we see the substitution right here. We take out the C, replace it with the 2 because we're told that C is equal to 2. Our second property is kind of an obvious one. It's called the reflexive property of equality, or the reflexive property of congruence. And it simply just says if A is equal to A, or A is congruent to itself. So in other words, the length of line segment AB is equal to just that, the length of line segment AB. Or for instance, we can use it to say angle ABC is congruent to angle ABC. Now, pretty soon we'll be writing proofs, and we use the reflexive property of equality or the reflexive property of congruence to introduce different things into the proof. We'll talk more about that later on. The third property is called the symmetric property of equality or congruence. Now, it's similar to the reflexive property, but it's obviously not the same. And it states, if A equals B, then B equals A. And I want you to notice how the order changes. If A equals B, then B equals A. You switch it around. Or if A is congruent to B, then B is congruent to A. So an example of this would be to say simply, if angle 3 is congruent to angle 4, then that's the same thing as saying angle 4 is congruent to angle 3. Again, notice the change in the order. The final property for algebra is the transitive property of equality or congruence. And it states, if A equals B and B equals C, then A is equal to C. In other words, if x plus y is equal to 3 and 3 is equal to A plus B, then x plus y is equal to A plus B. So when I think of the transitive property, I think of it as having 3 steps. If A equals B, notice how B ends that first statement, and B equals C, B starts the next little equation. And then finally we get A equals C. The very first thing mentioned is equal to the very last thing mentioned, the transitive property. In the second half of our lesson today, we're going to review a few definitions and postulates. The first one says the definition of an angle bisector. And the actual definition states, if a ray bisects an angle, then it divides the angle into 2 congruent angles. So our goal is to be able to recognize when this particular definition is used, and also to recognize how we can use it in a proof. So for instance, if we have a little picture of an angle, and let's call this angle CAD. Let's put point B right here on that angle bisector. And so if we say that AB, ray AB, bisects angle CAD, what we can take away from that is angle CAB is congruent to angle BAD. So again, we're looking to our postulates and definitions to ask ourselves, what information do we know just based on what's given? Our second definition is the definition of midpoint. So recall that a midpoint of a segment divides a segment into two congruent segments. So if we draw a picture, we have a line segment, and let's say that the endpoints are A and C. If we're given information that B is the midpoint, remember that when we're told that we have a midpoint, we should right away mark our diagram with what that means to us. So a midpoint tells us that it's a point that divides a segment into two congruent segments. So again, our takeaway from this is to say that line segment AB is congruent to line segment BC. Okay. Our next postulate, our first postulate, is the segment addition postulate. And this is one that we're very familiar with from the first unit. The segment addition postulate says that if we have a line segment and we have 3 points on the line, let's say points A, B, and C, and we know that B, that's this point right here, is between A and C because they are all in one line, they're all collinear, then we're allowed to say that the length of line segment AB plus the length of line segment BC is equal to the length of line segment AC. And if you wanted to, you could put some numbers in there just to make sure. For instance, we can say that the length of line segment AB is 1, and the length of line segment BC is 2, and then that would make the whole length of line segment AC 3 units. 1 plus 2 equals 3. Our final postulate for today is the angle addition postulate. And this is also from earlier in Unit 1.1. So if we just draw a quick picture of an angle, and let's call it angle ABC. Let's draw a ray, and let's label this angle with angle 1 and this angle with angle 2. And in this picture, to illustrate the angle addition postulate, notice how we can take the measure of angle 1, the little angle, plus the measure of angle 2, and together they form this larger angle, angle ABC. So we say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC.